Hi guys, I'm going to go through your Chapter 7 test review. It begins on page 321 and it's numbers 9 through 16, 18 through 21, 23, and 28. As you're watching this, you might want to also have your note card handy. If there are any formulas, examples you want to put on there, go ahead and do that. In number 9, we have this picture. We are trying to find the measure of angle YZA, this angle right here. Of the angles that we have expressions for, one, the 2x plus 50 is an exterior angle, and the exterior angle of a triangle is always equal to the sum of the two remote interior angles. The 40 and the x plus 50 are the two remote interior angles. If we add those, that should equal the 2x plus 50, that exterior angle. So that's how we're going to set up our equation. 40 plus x plus 50 equals 2x plus 50. We can clean it up a little bit. I've got x plus 90 on the left. I'm going to move my x over to the right, so I'm going to subtract 1x from both sides. So 90 equals just 1x plus 50. I'm going to move my 50 to the other side. So 40 equals x. Now the question was, what's the measure of angle YZA, where the question mark is? If I look at that angle, along with the exterior angle, the 2x plus 50, those I can see form this straight line, which means they are supplementary. So if I can evaluate the exterior angle when x is 40, I'll get 2 times 40 plus 50. 2 times 40 is 80. 80 plus 50 is 130 degrees. That's the exterior angle. So the angle next to it with the question mark, the measure of angle YZA is equal to 180 minus the 130, which is 50 degrees. And that's the measure of that angle. For number 10, we're told some givens. We're told that C is the midpoint of BD, so I know that BC and CD are congruent. We're told that E is the midpoint of BF, so I know that BE and EF are congruent. This also tells me that CE is a midline because it's connecting these two midpoints C and E. And because it's a midline, I know that its distance is half the distance of the third side, DF. I also know that it's parallel to DF. All right, we also know that DF equals 12 and that the measure of angle D is 80 degrees and the measure of angle B is 60 degrees. You can see that. Okay. So the first thing we need to find is the measure of CE. CE is our midline. Its distance is half the measure of that third side it's parallel to, which is the DF. So half of 12, which is DF, is 6. So CE is 6. The measure of angle BCE is next. BCE, and I'm just going to change colors really quick. BCE, this angle, is corresponding to this 80 degrees right here. Remember, we've got parallel lines. This can be like my transversal. So if this angle down here is 80, then this angle right here is also 80. Angle BCE, 80 degrees. Oops. The measure of angle BEC is the other angle of that top little triangle, this guy right here. And if I'm looking at the top triangle, I already know two of its angle measures, 60 and 80. Those add up to 140, which means that little tiny angle E, angle BEC, has to add up with the 140 to equal 180, so it has to equal 40 degrees. These are my three measures. In this example, we have to find the measure of angle 3. I can see by these ticks right here that this larger triangle is isosceles, which means that the base angles have to be congruent, which means this other angle is 70 degrees. if those two are 70, they add up to 140, which means this third angle has to add with the 140 to equal 180. So it has to equal 40 degrees. Now that's angle 3 along with this other side. Now my hunch is that they're congruent. Now we did start with an isosceles triangle. It looks like this would be an altitude. We know in an isosceles triangle that the altitude is the same as the median, which means if it's a median, that means these two segments are congruent. And by SAS, those two triangles are congruent, which means angle 3 and this other half over here are congruent. So all we have to do to find the measure of angle 3 is just divide that 40 in 2, and we get 20 degrees. Okay, number 12, it says an exterior angle of a polygon, of a regular polygon, is 15 degrees. Find the number of sides. So basically they want to know what's our n. Our formula for one exterior angle is capital E, and it equals 360 divided by n. In this case, this equals 15. I don't know what n is. So we'll say 15 equals 360 over n. To solve this, I would multiply both sides by n. This n in the denominator, would cancel. So now I've got 15n equals 360. And all I have to do now is divide both sides by 15. And we get that n equals 24 sides. So 24 sides. The name of this polygon would be a 24-gon. (13) tells us that this particular polygon has 33 sides. That means our n is 33. We need to find two things: the sum of all the angles and the sum of all the exterior angles. So that's capital S sub I and capital S sub E. The capital S sub I formula is n minus 2 times 180, and the capital S sub E formula is just 360. This formula we're done with, 360 degrees. That is the sum of the exterior angles of any type of polygon. Now we need to go back up to A and evaluate that. Our n is 33. So 33 minus 2, and then we'll times that by 180. 33 minus 2 is 31. 31 times 180 is 5,580 degrees. This is a pretty big shape. And there's the sum of all the inside angles. In number 14, we kind of have to work backwards. We're told that all the inside angles add up to 1620 degrees. It's the sum of the interior angles. We need to find the number of sides. So if we think about the formula for sum of the interior, the formula is n minus 2 times 180. All we have to do now is replace the S sub I with 1620, and then we'll solve for n. And we're going to start off by getting rid of our parentheses by distributing the 180. So we'll have 180 times n, which is 180n, 180 times negative 2, which is negative 360. All we have to do now is solve. So we'll add 360 to both sides to get all our constants on the other side. And we'll get 1980 equals 180n. We'll divide both sides by 180. And we will get 11. That is our number of sides. If it asks for the name of the shape, you would just call it, you could call it an 11-gon, but it's also called an undecagon. if you want to be precise. This question is kind of the reverse of how it was asked in our notes. In our notes, I believe it said we had 90 diagonals. If you have 90 diagonals, what's the shape? And then we solved, and n was 15, which means we have a pentadecagon. This one's telling us that we have a pentadecagon and wants to know the number of diagonals. So we already know our answer should be 90, but we're going to solve it anyways, because I think this is where, well, we need to practice using the diagonal formula. So the diagonal formula is n times n minus 3 divided by 2. If we have a pentadecagon, penta means 5, deca is 10, so that means our n is 15. So that's what we're going to replace for our n's. So we'll get 15 times 15 minus 3 divided by 2. You always want to do parentheses first. 15 minus 3 is 12. 12 times 15, and then divided by 2 is going to give you 90 diagonals. Now, if you were told how many diagonals and you had to set it equal to the diagonal formula and solve for n, you would start by multiplying both sides by 2, then you would distribute that n to the n and to the minus 3, and you know you're going to get a quadratic. So look back in your notes to see how you would solve that type of problem. All right, number 16 is one of those ones where it's this very long sentence with all these vocabulary terms, and you have to translate it into an equation. It says, look for your is, because that's where your equal sign is going to be. So everything before the is will go on one side, everything after the is goes on the other side. Before the is, it says the measure of an exterior angle of an equiangular polygon. An exterior angle implies 1. Our formula for one exterior angle is 360 divided by n. So that's all that goes on the left. On the right of the word is, it says that it is twice that of an interior angle. So twice means times 2. An interior angle, that is one interior angle. That's the I formula. So we're going to do 2 times that formula, and that formula is n minus 2 times 180 divided by n. Okay, so this is our equation. We need to solve this to figure out what n is. Then we can go back and figure out the name based on the number of sides. If you look at this equation, we have a denominator of n on both sides, which means if I multiply both sides by n, it's going to very conveniently cancel with both of our denominators, and that gets rid of a huge issue. Now we have 360 equals, I've got 2 and I have 180 on the right side, both outside of the parentheses. So I need to distribute both of those inside of the parentheses, but I might as well just do that together. 2 times 180 is 360. So what I'm going to do instead is just distribute the 360 to the n and to the negative 2. 360 times n is 360n. 360 times negative 2 is going to be negative 720. So here's our equation simplified. I'm going to move my constants to the left because my n's are on the right. So I'm going to add 720 to both sides. I'm going to get 1080 on the left equals 360n on the right. Then we'll divide both sides by 360, and that gives us 3 for our n. And if we have 3 sides, that means it is a triangle. And since it says it's equiangular, if I have a triangle where all the angles are equal, that's an equiangular triangle, which is also equilateral. So equilateral, equiangular, they're both the same. We'll just say equitriangle, and that'll take care of both of those. Number 18 can be solved in 2 different ways depending on how you look at it. Most of you are probably going to see it the way I'm going to solve it first. So it says you've got a right triangle. It says one of the angles is 5 times the measure of another angle. it doesn't say which two angles we're talking about. So I think most people are just going to naturally want to call our two acute angles these two angles. One is 5 times the other. So we could call one x and the other 5x. It says, what are the possible values of the measure of the second largest angle? If we were doing it this way, our second largest angle is going to be the 5x. The 90 is always the largest. And x is clearly smaller than 5x. So 5x is going to be the second largest. So that's what we're going to solve for in the end. But the equation we're going to set up is we're just going to add up all the angles and have it equal 180. You could also, you should know that in a right triangle, the two acute angles add up to 90 degrees. So you could, instead of adding all three up to 180, you could just say 5x plus x equals 90. You're going to get the same answer as if you said 90 plus 5x plus x equals 180. Because what's going to happen if you solve that second equation I wrote down first, the first thing you're probably going to want to do is subtract 90 from both sides. And oh, look what you have now. That's exactly what we have over here. So it just kind of saves you a step. Anyway, so let's go ahead and solve this. 5x plus 1x is 6x. And then when we divide both sides by 6, we get that x equals 15. Now we have to evaluate that second largest angle, which was the 5x. So we'll replace the x with 15. And 5 times 15 equals 75 degrees. This is the measure that most of you probably got. Okay, so since it didn't say which two angles, we can look at it from a different perspective. The angle that's 5 times the other angle could be the right angle. The right angle could be the 5x, and one of these acute angles could be the x. If that's the case, then that means 5x equals 90, because that angle equals 90 degrees. And if I divide both sides by 5, x equals 18. So now we're playing with a different x value. To find the measure of the second largest angle, I know the right angle is the absolute largest angle. This angle equals 18 degrees, because that's what x is. So the other angle is going to be something between 90 and 18, because it has to add with the 18 to equal 90. So I know that's going to be my second largest angle. So to find that, we'll do 90 minus its complement down here. And that's how we'll get, 70, let me just rewrite this, 72 degrees. So that's how you would get the other answer. So when you're doing these problems, don't always assume you know exactly what they're talking about. If it's ambiguous, try something that might work. You might be able to do it in more than one way. In 19, we've got quite a few givens. Our first given is that triangle ABC is isosceles with base BC. If base is BC, that means AB and AC are the congruent sides. Whenever we have isosceles triangles, we also know that the base angles are congruent. So angle ABC and angle ACB are going to be congruent. We're also told that ray BE bisects angle ABC, which means these two halves are congruent. We also know that CE bisects angle FCD. So these two halves of angle FCD are going to be congruent. And we know that the measure of angle A is 50 degrees. So the first thing we need to figure out is what's the measure of angle ABF. ABF was half of the base of that isosceles triangle. Well, if I'm looking just at isosceles triangle ABC, I already see this 50 degrees up here. So I know the two base angles have to add up to 130, so that all three angles will add up to 180. So if this angle and this angle add up to 130 and they have to be congruent, they're each going to equal half of 130. So they're each going to equal 65 degrees, which is half of 130. But this angle ABF is half of the 65. So I've got to just divide the 65 by 2. And what do we get? 32.5. That is the number of degrees of angle ABF. 32.5 degrees. Okay. Now we need to find the measure of angle BCE. BCE, BCE is the 65 plus whatever this is. Well, I know that that angle is congruent to this angle. So basically, and the three angles, the 65 with those two, should add up to 180. So if I subtract 180 by 65, we get 115. 115 is the measure of angle FCD, these two guys together, okay? The measure of angle BCE is half of that, this part, plus that 65. So half of 115 is going to be 57.5, I believe, if I did that right. But then we've got to add the 65 to that. So we're going to get 122.5. Yes, that seems correct. 122.5 degrees. The last thing we need to find is the measure of angle E. So let me get one more color. Okay, so let's take a look at this. Angle E is part of this triangle. Now, this angle right here is 32.5 degrees because it's half of that 65. This angle right here we just found was the 122.5. All we need to do now is add those, subtract from 180, and we'll get the measure of angle E. So we'll add the 32.5 and the 122.5. Make sure you're lining up decimals if you're doing this by hand. You've probably forgotten how to do this. Whoops. I got 155 flat. So if I subtract that from 180 to get angle E, we get 25 degrees. So these are your three angle measures that it's asking you for. Number 20 tells us a few things. It tells us that AB is congruent to AC, which means triangle ABC is an isosceles triangle. And we know that these two base angles should be congruent. We're also told that angle DBC is congruent to angle DCA. DBC is this one. DCA is that one. And we're told that the measure of angle A is 50. We need to find the measure of angle BDC. So let's think about this for a sec. Okay, this one, I've got to use some logic here. So here's the deal. I've got an isosceles triangle. The vertex angle is 50, which means the two base angles are going to be congruent, of course, and they're going to add with the 50 to make 180. So together, they're going to add up to 130, which means they're each going to be 130 divided by 2, which equals 65. So this angle and this angle are 65. Now here's where some of you are going to get stuck. If we subtract out this angle and this angle from those two 65s, we're going to be left with this little guy and this little guy. And those two little guys are going to be congruent because we're subtracting equal amounts from equal amounts. What that means is then, if I added, all right, let me get another color. So let's take a look at this little triangle right here, okay? We need to find the measure of the angle where the question mark is. On the left side, we've got this 2-arc angle. On the right side, we've got this 3-arc angle. And we don't know what either of those equal, but if you look at the measure of the larger angle C, it's made up of a 3-arc and a 2-arc. So I don't know what they are individually, but I know that they add up to 65 because I know that measure, that big angle C, equals 65 degrees. So what that's saying, and I'm going to redraw this little triangle, is that while I don't know that angle's measure, and while I don't know this angle's measure, I do know that these two add up to 65 degrees. Let me give you my vertices so you can be with me. Okay, so it doesn't really matter what they equal individually. Together they equal 65, which means I can very easily find now the measure of angle D, because I'm just going to subtract the 65 from the 180. And when you do that, you get 115 degrees for the measure of angle D. Okay, we've got some always, sometimes, nevers for 21. 21A, an equiangular triangle is isosceles. If I have a triangle that's equiangular, which means all the angles are equal, we know that it's also equilateral. All the sides are equal. And if it's equilateral, it's got to also be isosceles. Isosceles just means at least two sides are congruent. So this is going to be an always. B, the number of diagonals in a polygon is the same as the number of sides. At first glance, I would say sometimes sides, there can be more sides than diagonals, such as in like a quadrilateral. Four-sided shape only has 2 diagonals. But then if I start adding sides, I'm adding lots more diagonals. So sometimes there are more diagonals than there are sides. So like in a pentagon, we've got all kinds of diagonals. I think we've got 5. In that one, they're equal. But then if I get even bigger, like in a hexagon, 1, 2, 3, 4, 5, 6, 7, 8, 9. Got 9 diagonals. In this case, I've got more diagonals than sides, but I started off with less diagonals than sides, and in the middle they were equal. So I guess this one would be a sometimes. It depends. C, an exterior angle of a triangle is larger in measure than any angle of a triangle. Well, it also depends how it's drawn. I could draw the exterior angle here, and I can see that it's acute. Well, it's not larger than this angle because this angle is obtuse. So that just disproved it. If I draw my triangle like this, and this is my exterior angle, this angle is obtuse, and it is bigger than all 3 of these inside angles. So in that case, it'd be true. So this one would be a sometimes. D, one of the base angles of an isosceles triangle has a measure greater than that of one of the exterior angles of the triangle. So let's think about it. I've got an isosceles triangle. I've got these 2 base angles. Has a measure greater than that of one of the exterior angles. Well, in an isosceles triangle, so I'm going to assume that this isosceles triangle I drew is acute. All the angles are less than 90, which means all the exterior angles are going to be greater than 90. So in this case would show that it was not true. I need to show that one of the base angles, is greater than that of the exterior angles. Okay, so let's think, what's the biggest base angle I can have? If I want my base angles to be really big, then I need to minimize that vertex angle, right? let's say my vertex angle was 10, something very small. Then these two base angles would have to add to 170, which means they're each going to equal 85. What I'm trying to do is find a base angle that's going to be bigger than one of the exterior angles. Well, the exterior angles right here, if these base angles are 85, then this is still bigger than both of those. If I look at the exterior angle right at the vertex, this one is 170. The base angles are still smaller than that. So I'm thinking this one should be a never. This is not possible. 23 is asking about an arithmetic progression, which just means that the difference between the numbers in the sequence is always the same. So in the example they gave you, they said 1, 5, 9, 13, and so on. I can see that the difference is 4. I'm just adding 4. Okay. So, this one says, do the number of diagonals in a triangle, quadrilateral, pentagon, and hexagon form an arithmetic progression? So, in a triangle, we have no diagonals, so that's going to be 0. In a quadrilateral, we have 2 diagonals, so that'll be 2. In a pentagon, and we just did this on the last example, a pentagon's got 5 diagonals. And then a hexagon, we said, has 9 diagonals, I believe. Whoops, I just drew a pentagon again. 1, 2, 3, 4, 5, 6, 7, 8. No, it's just 8. Okay, so we want to see, is there a common difference? We have a difference of 2, 3, and 3. So it would have worked if we didn't have this 2, because the 3 would be common. But unfortunately, this is not an arithmetic progression. So the answer is no, because we don't have a common difference. All right, 28 is a probability question. It says we've got in a drawer a regular triangle, a regular quadrilateral, which would be the square, a regular pentagon, and a regular hexagon. It says the drawer is opened and an angle from one of the polygons is selected at random. Okay, I'm going to pause there. An angle is selected at random. It wants to know something about the measure of these angles. So I need to first think about, well, what are going to be all these angle measures? If I've got a regular triangle, all my angles are congruent. Remember, to be regular, all the angles are congruent. So each of these are 60. So I've got 3 60s for the triangle. In a square, my regular quadrilateral, I know I've got 4 90s. In a pentagon, I can find the measure, n is 5, right? You can find the measure of 1 by doing n minus 2 times 180. This is the capital I formula divided by n. And if you plug in n with 5, you get 5 minus 2, which is 3, times 180, which is 540, and then divide that by 5, you should get 108. So in this case, we've got 5 108s. Let me just erase this real quick, so kind of clean up my area. And then in a hexagon, we can do the same thing. We can use the same formula. Plug in 6 for n, so 6 minus 2 times 180, and then we'll divide that by 6. 6 minus 2 is 4. 4 times 180 is 720. 720 divided by 6 is 120. And we've got 6 of these. So I'm just trying to list all my possibilities. Okay, So these are all my angles. It says, what is the probability that the measure of the angle, so let me go back. It says the drawer is opened and an angle from one of the polygons is selected at random. So I'm just picking one. I'm not picking pairs. If you're just picking one, you don't have to list out all the combinations of two. I've got all my combinations of one already listed. So it says, what's the probability that the measure of the angle is an integral multiple of 30, which just means I can divide it by 30 evenly. So first of all, we got to figure out what's our total. We've got 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18 possible angles to pick. Now the ones that can be divided by 30 evenly, I'm going to check off. I know 60 is divisible by 30. I know 90 is. 108 is not. I know 120 is. So if I add up the ones that are checked, I've got 7 and 6, which is 13. The 108s don't count into that, so 13 out of the 18, that does not simplify. That is your probability. So if you have any more questions, just swing by my room before school on Friday. I've got Friday tutoring in the morning, so just come by my room with any questions you have, and we can go over those. Good luck studying.